In this media, you will learn about phase change over switch. Consider a typical house which has three-phase power supply connection. All domestic appliances are connected with three-phase supply through the main switch. In most of the cases of supply failures, loss of supply in a single phase is common and frequent. Under this condition, supply will be available in the residence in two phases. So, the appliances which are connected in the interrupted phase could not be operated. If an important appliance, such as mixer grinder, has been connected in the interrupted phase, cooking will be affected very much. By providing inverters with batteries, supply could be made available for lighter loads, such as fans and lights. But feeding a mixer grinder from an inverter means that the capacity of the battery and inverter has to be increased to very high values. Then, the inverter cost also becomes high, and it is unaffordable for middle-class families. The phase changeover switches can be used to obviate these problems. These phase changeover switches are connected between three-phase supply and the main switch as shown here. Assume the R phase gets interrupted. So, the loads connected with the R phase can't be used. Under this condition, the loads with R phase can be changed to another phase, Y or B, by using phase changeover switch. Hence, it would be possible to get supply in all the points in the entire house, even if two phases have failed. But the heavy loads, like geysers, washing machines, cooking ranges, grinders, and so on, should not be run simultaneously in one phase. The loads may draw more current from the available two phases. This high current flow may affect the wiring system. Thus, you have learnt about phase changeover switch. Uninterrupted availability of supply has become the basic necessity nowadays in electrical distribution systems in consumers' premises. This media deals with such a typical scheme practically used in multi-story buildings. Electric supply is received at 11 kilovolts level from utility. B1 sub M is the circuit breaker at the incoming point. It is manually operated. After the fuse meant for transformer protection, there is the 11 kilovolt, 440 volt, 630 kilovolt amp transformer designed with a capacity to feed the entire load. A diesel generator, DG, with 630 kilovolt amps, 440 volts, is available to feed all the loads in the event of non-availability of utility supply. The breakers indicated with subscript A are auto-operated, and breakers with subscript M are manually operated. Under normal conditions, utility supply is available, the DG is idle, and the breaker B5 sub A is in open position. Breaker B1 sub M is now closed. Manual operated breakers B2 sub M, B3 sub M, B6 sub M, B9 sub M, and so on are normally in closed condition always. B2 sub M and B3 sub M are used to isolate the 440 volts bus and the subsequent portions to take up major maintenance or troubleshooting electrical works inside the building. Hence, the supply is available at point U. The voltage sensing relay at U automatically closes the breaker B4 sub A. Now, supply reaches the 440 volt bus in the ground floor. The various loads now get supply in the ground floor. Supply is simultaneously extended to other floors through the double circuit feeders, DF1 and DF2. At first floor, an automatic scheme is provided such that one of the breakers, B7 sub A or B8 sub A, closes first depending upon the time settings of the timers of B7 sub A or B8 sub A. If one breaker closes, it blocks the closure of another breaker. Assume that breaker B7A closes. Now, 440-volt bus at first floor gets supply, feeding all its loads. Case 1. Failure of utility supply. The control scheme of DG is normally kept in auto position. When utility supply fails, breaker B4 sub A is opened automatically by the voltage sensing relay at 440 volts bus at ground floor. And hence, supply at 440 volt bus at ground floor is lost. Breaker B7 sub A is also opened automatically through the voltage sensing relay in its control scheme. The voltage sensing relay at 440 volt bus at ground floor also starts the DG automatically. DG picks up to normal speed and voltage within some seconds, and the auto scheme in DG circuit makes the breaker B5 sub A to close automatically. Breaker B7 sub A closes as before, extending supply to first floor once again. The same scheme is followed in other floors also. Case 2. Now utility supply comes back. The voltage sensing relay at U operates and opens the breaker B5 sub A and shuts down DG. And subsequently, breaker B4 sub A closes, restoring the supply to the floors as described before. Case 3. If you want to run the DG set even when utility supply is available, you have to open the breaker B2 sub M manually. The sequence then follows as in Case 1. Case 4. If you want to run the DG set on trial when the utility supply is available, open the breaker B3 sub M, and then you have to put the control of DG in manual mode and run it. The breaker B5 sub A will not close in this mode. There is also a test mode for the DG. If the DG is started on test mode for trial run, it will run for nearly 2 minutes and get shut down automatically. And the mode will change to auto. In this exercise, you will learn how to install energy meter in domestic consumer end. Take a teak wood board and mark the positions for drilling holes. Drill holes on the marked points using a hand drilling machine. By placing the teak wood board on the wall, mark the 4 points for making holes using a scriber. Make holes on the marked points by hammering the rawl bit jumper. Insert wooden rawl plugs into the holes. Mark the position for meter, ironclad double pole switch box, and earth plate in the teak wood board. Fix the energy meter, ironclad double pole switch box, and earth plate in the board. Fix the assembled board in the wall. Connect the supply cable to the meter. Connections are made with correct polarity with reference to the catalog of energy meter. Seal the external cover of the connection box in energy meter. Connect the outgoing cable of the meter to ICDP switch box. Earth the casing of meter and ICDP box with the earth plate. Connect the earth wire to the earth plate. Finally, cover the entire setup with a wooden box.